Alright, so how you doing, everybody? So this is an odds and sods video, and I'm working on a bunch of stuff, and I just want to give you an update of what I'm working on. And what you're looking at here is a Class D amplifier setup that I'm working on. These are all Chinese boards. You know, they cost about 15 bucks each, no more than that. And supposedly Class D, you know, this is a Class D obviously, and you can get about 200 watts of power out of these things. So what my plan is to build a bass amp out of them. This is the power supply. It's a 55 volt power supply, which means there's a 55 volt output which goes to the amplifier, and there's also a 15 volt output that will go to this tone board, but we're going to talk more about that in a moment. So power supply, it looks like it's fairly well made. I put it on the scope and checked it. It's stable. It's, you know, it's Chinese, right? You don't know what you're going to get. This is the amplifier board itself. This is 200 watts of power. It's mono, so there's only one channel. And this is what we're going to use to power our bass. Look at the size of this thing. I mean, let me give you an idea of how big it is. Here's a wire nut. I mean, there's not much to this thing. Huge heat sink on it. And again, you know, China, you don't know what you're going to get. But we're going to play with it. And this connects directly here to this board to the 55 volts. That's what these wires do. And then this is a preamp / tone board. All right, so basically what happens is your signal comes in here, goes out of this connector, which is supposed to be connected here like this, comes in. This is your preamp and your tone, comes out, goes into the amplifier, and of course this powers everything. So this is also powered off this power supply. Now the problem with this particular tone board that I have is it really isn't going to solve my needs for my bass, and the reason why is this is more of a auxiliary type board. You see it's got RCA jacks, and it's really not driving things the way we need to drive them. So so we're going to end up building our own little preamp here, and I'm going to show you the one that I'm building just for testing purposes. So let me do that. Yep, you've guessed it. We're going to build ourselves a tube preamp. Now this is just a prototype here. This is an old chassis I had laying around. I've got an Edcore transformer here. Here's a 12AX7, and then underneath, you know, we've got everything laid out properly. And you'll notice I don't have any tone controls in this thing. All I have is one pot here, which lets me adjust how much power this thing puts out. And the ultimate goal here is we want to put out 2 volts on the output, and that's what will drive that amplifier the way we want it to be driven. And we've proven that through some experiments that we've done. But this is the preamp circuit. All we need to do now is add the tone control, and that gets done just by replacing one of these caps. This is a 0.02 cap. You take the cap out, you put in your treble, bass, and mid, and you've got tone controls. So that's what we're going to do, and then we're going to put all this together and test it. Now the thing with Class D, which I'm going to get into in a separate video, I'm not going to go into a lot of theory about Class D, but I want to explain to you just like quickly what Class D really is. So as you know or may not know, in amplifiers there's Class A, there's Class AB, and there's Class D. And there may be some other classes. I'm not going to go into those. I'm going to talk about those 3. Typical amplifier is Class A, right? That's where you have one output tube possibly. You have a preamp stage and you have an output stage. And the way that you think about a Class A amplifier is that the full power of the amp is always on. So let's assume for a minute that you're going to wash your car. All right, and what do? You take the hose, you put the nozzle on it, and you turn the water on outside, and you put the hose down, and you get the car ready, and you soap it up, and then you pick up the hose and you squirt it. Well, Class A, you're leaving the hose running constantly, even when you're not using it. It's just sitting there pumping out. That's what a Class A does. It just sits there and pumps out its capacity, and when you use it, you're using it, but it's always on. That's the problem. Class AB is a little bit different. Class AB has a negative bias to it, but it's essentially the same principle, where the power is always on. It's just in a Class AB, because you're using negative bias, it's a little bit different. I'm not going to get into theory here. Class D is more from an analogy perspective. It basically delivers the power when you need it. Okay, so the power is there; it's ready to be used, but it doesn't leave it full bore when you're not using the amp or you're not playing a note even. Class D uses pulse wave modulation. So basically your signal comes in as a sine wave, it gets mixed with a frequency, it gets you get pulse waves, and I'll show you this in a future video with a demo. When you see a square wave, it's got a pulse, and as you pluck the note on the guitar, the pulse will be longer or shorter, and that's how it works. And again, this is really high level here, guys. So don't tell me I'm wrong yet until I give you the explanation. But pulse wave is really cool, and you see it on that amplifier board that I showed you, the 200 watt amplifier board. So I'll demonstrate that in a future video. But this is what we're doing. So we're going to build our preamp with the tone controls. We're going to connect it to this amplifier board that I showed you. We're going to get rid of this tone board that's going out. This is the preamp that we tried initially. That's out of here. And then we're going to connect it all together. And then the only other thing you got to do is you got to get a good speaker, right? So you have to have a speaker that's capable of at least 200 watts, because that's what this thing can pump out. Now, one disclaimer: Chinese stuff always claims that it's more than it is usually, right? They use different methods to measure things. I've actually taken this setup with this preamp and did a little test on the scope and the audio generator, and I was able to get about 116 watts before the signal started to break up. So, which is fine for bass. I mean, you really don't need more than that. You don't need anywhere near that actually. And I was vibrating the speaker like crazy. So so I know it's going to work. So that's the story with this. This is what I'm working on, and you will see more about this in a future video. So let me show you the last thing I'm working on, and then we'll wrap it up, and then we'll come back to you with individual series for these things. And we should be right back when I snap my fingers. And here we are, and we have ourselves, I don't know if you can see this right here. It's a Fada radio. Cue the music, Johnny.
Hello, Mother. Hello, Fada. Here I am at Camp Granada.
Okay, we're back. So we're working on a Fada radio, and this is a wooden case radio. It's a model 68. These models are pretty rare. I haven't found a lot of them. Now, I know one thing about Fada. Well, actually, there's a whole history on this thing, and I'll cover this when I do the video. It was based in Brooklyn, Long Island, New York. Really high-end. Yeah, I'm sure most of you know the really expensive Fada radios, the ones that are colored plastic and bakelite. This is not that, obviously, but someone painted this thing. And what I've been doing is just experimenting to take off the paint and see what's under there. And you can see we've got some really nice veneer on this thing. I've done the entire top, and I don't know if you could see this or not, but it looks like we have book-matched, it looks like it may be oak. And you can see it's book-matched because we've got the same pattern on both sides of the seam here. So I've taken this down to the wood, and we're going to obviously try to restore this as close as we can. We don't want it to be perfect. We want it to be back to where it was. And I've got a lot more to do here. You can see this side is all painted. I've got some repairs I need to do to the veneer, like so. The entire front has to be done. There's the speaker, and then we've got a curve on it, and we go around. And then on the inside, I've already reinforced it. There were some loose joints. I've already clamped it. This entire thing was out of alignment right here. This was right here as well. I had to clamp this. So the wood cabinet's in actually decent shape. So we're gonna get this done. Let me show you the chassis, and we'll go from there. Right back. Okay, here's the chassis. It's a standard All-American 5. I love these coils that are exposed. I think that's a really cool look. Tuning cap is there. It's dirty, obviously. Didn't come with any tubes, but that's fine. It looks like it uses the old style 8-pin tubes, octal sockets, I should say. And we've got a rectifier tube. We've got a Fada speaker. Here's an electrolytic. Here's our dial. It's got a really cool looking dial, and it's got broadcast band and shortwave. Police band, and aviation, amateur. It's got a whole bunch of stuff on it, so this is really cool. Speaker's in great shape. And then underneath, it's really not much going on. It's really not much to it. Of course, we have the infamous band switch, which is fine. But we don't have a lot of caps here, and I haven't powered it up, obviously, because first thing I saw was this cap is disconnected, so I have no idea what was going on under here. So, so we're going to get this back to a usable state, and then we're going to obviously do the cabinet. On this chassis, I notice there's a lot of rust, so we're going to have to take care of that. And here's the back, and there's a lot of rust here, so we're going to have to pay a little bit of attention to this. We'll do that. I may just strip the deck here and clean the whole thing and put it back together. I have to decide what I'm going to do. There's actually 6 tubes in this thing. I just found this other one. It's covered in dust. So anyway, so maybe it's not an All-American 5. Anyway, whatever, we'll figure it out. So there's not a lot of detail on this thing. That's the thing, right? If you go do a search on Radio Museum, they have a picture of one of these radios. I can't find a lot on a FATA Model 68. I found a 68T. Now, what FATA did, if you look at if you just do a little, brief view of their history, they built their cabinets to accept different model radios. So I think I suspect that this, model is probably used in other radios, this chassis, but I haven't really figured that out yet. And here I have the knobs. We'll talk about that for a second. So, FATA knobs. These are pretty cool. So, the knobs are always the knobs. And here's the band selector. So we've got that protected right now. So we're going to work on this. So this will be a nice little radio, and like I said, they're fairly rare. So if I can do it the right way and not make it look like it's not meant to look, I don't want to make it perfect. I want to make it look like it looked when it was built. So that's the plan. So FATA Model 68. All right, let's put this away.
Something, whether he likes it or not. I appreciate this. Tommy appreciates it. And I'm sending you something, Ron. And you're going to see what it is right now. All right, I hope you can see what's on the bench here. About a year ago, 2019 to be exact, I went to a ham auction and I bought this Ungar desoldering station, which I made a video of. It needs a compressor. I don't have a quiet compressor. I have very, very loud, noisy compressors. I'm not about to use them.
All right, here we're looking at the Ungar Hot Vac 2000, which was sent to me by Bill, old 64 Goat. Wanted me to have it. I appreciate that, Bill. And we're going to take a look at it and see what's going on. So the way this thing works is you turn this on. It heats up this soldering iron type device. And what you do is you connect it to a compressor. And I have a compressor. I'll show you that in a moment. And theoretically, you get vacuum out of this thing. All right, so you've got a vacuum meter here. So I have to think about how this works. So air comes in. There's a valve here. I imagine the valve is always closed. And the reason why they do that is when you don't have the button pushed on this, all the air pressure doesn't escape. So it's an always closed valve. And when you push this button here, it'll release a solenoid and let the air flow through. Now what I don't understand is when the air flows through here, and there's a little bit of a tube that goes here, how does that create vacuum? If air is flowing this way, right? How does it create a vacuum? I don't know how that works yet. It's probably some electrical or mechanical design principle that I don't understand yet, and I'll look into it. So I have connected it to the compressor, and the iron does heat up, but there's no suction. Actually, the opposite happens. When you push the button, you get hot air blowing out of this thing, which can't be right. I did unclog it, so the tip was clogged right here. So I was able to fix that. So now I do have good airflow through this thing. And there is a reservoir back here where all the solder goes when it works. You take out that piece of cotton, and it collects inside there. I'll see if I can take that out and show you, because I haven't seen any videos on this model. I just don't know. It's like kind of it doesn't exist. I don't know what the story is with this thing, but it's made in the 70s, I think, so maybe that's why. So you'll see here there's a piece of cotton there with some solder on it, and when you push the button, the suction is supposed to pull it in, and it collects here, and you just change the cotton. And this is a sealed unit right here. It's got a washer on it. So that's the story. So let's rip it apart and see if we can figure out what's going on. I'm going to take that valve apart, because I remember Bill saying that the valve was no good. So we'll take the valve apart and see what it looks like. Let's take a peek. Okay, so we know that the vacuum is not working on this thing, and we took the pump apart. And this is the pump. It's actually a valve. It's an electromechanical electric valve, and we've taken it apart because it doesn't work. It's kind of seized. So let's get the phone and then we'll come back. Okay, so we're back. So we've taken it apart. So here's the inside, and this is the spindle that goes on top of it like this. And I'll show you really quick. It screws in. It's got threads on it, and it just basically screws in like this. And when you take it apart, you've got a seal, and you have a cylinder with a spring. And what happens is when you power this thing on, this is like a magnet, right? And it basically takes this piston and moves it into the proper position. I haven't figured out how yet. I don't know what the position is, but I do know that the center hole is attached to this port, and these two holes is attached to this port. This is where your air comes in, right here. So I would imagine the air comes in here through the inside of the valve, and that's the part I don't know. So I'm trying to figure out how this works, because here's the spindle. This goes inside the spindle like this. So I would imagine that because this is an always open valve, there's always open valves and always closed valves. This is an always open valve. So I would imagine that when you apply the magnetic field, this thing is going to go in instead of out. But I don't know. I don't know. It could be the opposite. It could be that the force pushes it against this. And let me test the theory out here, by the way. If I put this here, which is where it goes, it doesn't really mean anything. Those holes don't get covered. So I don't exactly know how this valve works. I need to play with it a little bit more. So when I fully understand how it works, I'll come back and tell you. But we've got the valve apart, and we'll see if that does it. We'll be back. Okay, this segment is called Experimenting with Ron. So here we have our compressor connected. We've got everything put back together, and we're going to see if that solenoid actually works. Now, I can tell you right now that it's closed, because you don't feel the air coming out of it. I'm going to wait till this thing charges up again, the compressor, and then I'll show you what I'm talking about. So, let's see, where are we? Alright, we should be just about there. I'm going to wait till the noise stops. It should shut off in about 3 seconds. Okay, so we have air pressure in here right now, okay? So I'm going to turn the power up on this. I have it connected to my Variac, and watch what happens. You're going to hear a click, and then you're going to hear the air come out. Right there. Okay? So that's the equivalent of pushing the button on the desoldering tool. So let me turn this down. Okay. So what I don't understand is, here's how this works. Let me disconnect this. Okay. So here's what I don't understand. So the air comes in through here, goes through, engages this valve and opens it so that the air flows out here. And it comes out this little hole into a tube. And there's also, I guess, a regulator here. That's what this is. And when you get into the machine, it goes into this tube, which goes to this vacuum gauge and to the soldering tool. What I don't understand is, if there's air blowing in through this tube, how does that create a vacuum? That's the part I don't understand about how this technology works yet. So I'm going to try to figure that out. It should be going the other direction, right? The air should be coming in this way. It's a vacuum. Why is it pushing air in when it should be going out? I don't understand that. So I'm going to play a little bit more, and I'll let you know. Okay, we have it back together. It's still not doing what it's supposed to do. I'm going to have to save this for another day and see if I can figure out how this vacuum works. I'll do a little bit more research and maybe we'll put it in another odds and sods video. All right, so the last thing I want to talk about is this COVID-19 stuff. So as you know, I live in Jacksonville, Florida, and COVID is still here. It didn't go anywhere. Of course, when there's riots, it's not here. But that's a whole different discussion for another day. COVID is on the rise here in Florida. Matter of fact, I was supposed to have a fairly big gig tonight. Big gig for an anniversary of a company or a place that we play. And I decided to cancel it, honestly, because I don't want to be responsible for people getting sick at a gig that I'm playing. The way I look at it is, it's fun to play for 4 hours, but if I play for 4 hours, there's going to be a lot of people there, and one person gets sick. People don't think about what could happen, right? You have to stay away from your family. It's obviously the symptoms can be pretty bad. So I just decided it's a good thing not to do it. I'm not a fanatic. I've never worn a mask yet, but I'm careful, right? So I'm not one of those fanatics, but I just see the spikes of cases going up and people that I know all of a sudden. And the reason why I really made the decision is one of my friends played a gig at a local place here last Friday, and he gets tested regularly because his wife is in the medical field. So he was tested right before the gig last weekend, and Tuesday he tested positive, and he's really sick right now. Only because he was in a club with a bunch of people playing and obviously breathed something in, and he said he was really carefully wore a mask on breaks. Didn't help. So out of abundance of caution, I thought about it and said, if I play, first of all, I can't see my dad for Father's Day tomorrow. I have to self-quarantine for 2 weeks. That sucks. And I said, what am I going to do here, right? Am I going to cause the same thing to happen in the place that I'm playing that happened to my friend? I don't want to do that. So I made the decision. It's a tough one, but sometimes in life you have to make tough decisions. That's how it works. So we're just hanging tough here, and we'll all get through this. So I hope all of you are staying safe. Hope you enjoyed the little walkthrough of the projects that we got going on here, and you'll start to see some more detail on every one of them coming up. All right? Until then, we'll see you guys around. Take care.